Okay, all right, guys. Welcome to Rady Lesson Examples Day 3. Today, I'm going to do some, you're going to do some. We have 6 examples to work through. I'm going to do the first one with you. Then I'm going to have you do 2 and 3. I'm going to have you pause your video and go do 2 and 3. After you do 2 and 3, come back and see what I've put on paper and make sure it matches yours. Then we're going to do 4 together. And then I'm going to do 5 with you, and then you're going to turn off the video and do 6 on your own, and then come back and see if it matches my work. 2 things going on here. One is the video won't be as long, hopefully. There's a lot to teach here. And 2, you're going to start learning more and more about this stuff. So remember, Rady stands for roots, asymptotes, tangent or togetherness, in behavior, and y-intercept. It's just an acronym. Hope you all are doing well. So here's our first example. The top has degree 2, okay, and the bottom has degree 1, which means it's top heavy, which also means that we're going to do long division, okay? So we don't do a whole lot of stuff with division. You know, it's here and I'm forcing it on you, but it's not that hard. So if you are afraid of it or worry about it, just follow my lead. It's not so bad. So the first thing I'm going to do is look at the top, and I want to know if it has any roots. So I ask myself, is it factorable? And it doesn't factor because there's no 2 numbers that I can multiply to get 2 and add to get -2. So another thing you can also do is check the discriminant, b squared minus 4ac. If you do that, you know, the square root, it has to be positive in order for there to be a root, or it can be 0 and there would be a root. Well, b squared would be 4 minus 4 times 1 times 2, and you would take the square root of that, and that would be the square root of 4 take away 8, -4, and that means no, there are none, okay? So this is just another way to check for roots. Just use the discriminant to see if they're there. So if you look at something and you're not sure it's factorable, do b squared minus 4ac. This value has to be 0 or positive for you to have a root. Asymptotes, bottom. X plus 2 equals 0, so x equal, here, I'm going to do it here. X equal -2 because I'm going to need that room. So at x equal -2, we know we have asymptote. That's the word I'm looking for. All right. So I'm just going to take my orange marker out. I should have used red. That's what I've used the whole time, and I just grabbed orange. Oh, well. As long as you label it. When you're doing this for me on any test that I give you over this stuff, you have to label everything. So there's no ambiguity, no questions. It's all there. Okay? Now, is there any special? Are there any special? No, there's none. Okay. Why don't we just do this real quick? If I put a 0 in here, here, and here, I get y equals 2 over 2, which is 1, which means 0, 1. 0, 1 is a y-intercept. So I'm going to put down my y-intercept. We don't have any roots, so we know it's not going to be there. And it's top heavy. So what I'm going to do is I'm going to take the denominator and I'm going to divide it into the numerator. Okay? And the way I do this is I just say, what do I need to multiply x by to get x squared? X times x is x squared. So here is these are in descending order, so I don't need any placeholders. Now I take x times x and I get x squared. X times +2 is plus 2x. Now what I'm going to do is take this polynomial and subtract that one, and that's why I change the signs. So this becomes 0. This becomes -4x plus 2. I bring that down. X times -4. Here is my slant asymptote. Y equals x minus 4. So for y equal x minus 4, I'm going to go find -4 because this means my slope equals 1 over 1, and my y-intercept is 0, -4. So I go here. Since it's a slope of 1, up 4 and over 4 is slope of 1. So I'm just going to line up these 2 points, and I'm going to draw in my slant asymptote. Okay? Now, this whole process of graphing rational functions is like playing detective, okay? So I know this point is on the graph. That's my y-intercept of 0, 1. Since I know it's on the graph, I know the graph has to pass through here, but I also know it will not cross the x-axis because there are no roots. So I know that this function has to be going like this, and then it's going to chase, and then it's going to chase. So remember, a slant asymptote and a horizontal asymptote, okay, they just describe in behavior. So as this x-axis goes to positive infinity, then we say the function is going to f of x, the y values are going to positive infinity, okay? So as these numbers get big, these numbers get big, okay? Then to finish it off, I'm just going to draw in a bottom half because it's going to be mirrored. So what I want you to do is stop the video, and I want you to go do example 2 and example 3. I want you to do 2 and 3, okay? And then turn the video back on to see what 2 and 3 look like.